Okay, so hello everyone. I'm Alex Furlis. I'm working as R&D project manager in Vidavo, and today we will present our custom wearables and how is able to integrate them to your research projects and business activities. It is important to mention that this workshop is funded from the EU and the SAPES project. So let's see the agenda. First, we will present the Liberty project, which is a project selected from the SAPES consortium in the framework of the first open call. So we are first open call winners, and today we'll present what this project is and a few characteristics and advantage of using a Liberty device, how we've done the integration with the SAPES technology platform. SAPES technology platform is a solution, is a framework of different kind of digital solution supporting specific use cases on the healthcare domain. Also, we will continue the presentation explaining how we can have the same device, the same Liberty device, and to support other use cases in the healthcare industry and a success story of them. First of all, just to say a few things about Vidavo. Vidavo is a digital health company established in 2002. For these years, it has constantly invested in scientifically proved market-focused products exclusively on the healthcare sector. Our solutions cover a wide range area of connected health and self-management solutions for supporting chronic diseases, nutrition, and weight management, mainly with medical software. So this is important. The software that Vidavo designs and develops follow specific guidelines set from the European Union related with the MDD regulation and the most recent MDR regulation. So beside on that, the past 3 years, our research department is dealing with medical device development also, and machine learning at the edge. Machine learning at the edge, it means that we are able to run complex neural networks and AI models on wearable devices, on gateways, without that are used in the field, in the physical area of the solution, without having any connection with other components or even the internet. So what is SAPES and what is Liberty? As we said before, SAPES is a big European project dealing with several kinds of healthcare solutions from different vendors around Europe with a big amount of users already tested in their pilot sites all around Europe, these pilot sites. So we have been selected with the solution Liberty. Actually, Liberty is a custom wearable device. It's a solution that Vidavo tries to launch in the research industry, where users, companies, and research entities can perform their research activities without being necessary to develop their own hardware. We know that developing your own hardware is expensive and hard, takes time. So we provide a platform, a hardware platform with custom firmware and components to develop your own firmware on the device. And of course, we are giving access to all data extracted, all the raw data extracted from the device in order to support further business and research activities. So the specific use case for the SAFES project, which is Liberty, is a wrist wearable device able to calculate heart rate, respiration rate, blood oxygen saturation, body temperature, and steps and calories. So you can understand that we have a PPG, photoplethysmogram sensor, able to give us raw, red, and infrared radiations in order to perform the respective digital signal processing techniques in order to extract these vitals. And also our custom wearables are equipped with a 9-axis gyroscope and accelerometer in order to perform gesture recognitions and recognize steps and calories. So running the neural network on the wearable device, on our custom wearables for this use case, is a neural network able to classify patients' respiration. It expects as an input raw infrared and red radiation, and as an output, we can classify patients' respiration and we can identify bradypnea or tachypnea. So all this data, the neural network data output and the vitals we mentioned before from the digital signal processing techniques are stored locally on the wearable device and on specific intervals. The Liberty device make them available for third-party solutions. These third-party solutions can be software, can be mobile applications, can be gateways that they know our open source interface and open source communication protocol on how to retrieve this data to their systems and then post them on the SAPE's cloud infrastructure. So these are our wearable devices, our custom wearable devices. You can see the sensor on the top, the screen on the upfront, and also the button, the touch button that we have. So Liberty devices are equipped with 0.96 inches IPS screen, and the touch button is a feature that gives users the ability to navigate on different pages on the wearable device and see different kind of matrix. Also, it's really important to mention that we have Bluetooth, BLE capabilities, and Wi-Fi. On the SAPES project, we're using only the BLE capability since it supports better the use case, the specific use case, but also we have this option. We're using a 9-axis intermeasurement unit with accelerometer, gyroscope, and magnetometer in order to perform gesture recognition and measure the steps and calories. Also, we mentioned that we have a PPG sensor that give us the probability to calculate different kind of vital signs, and you saw that the vital signs we are supporting, and right now we're working on blood pressure also and blood glucose. So having access on raw data, it's really important because you can build your project, your product in time. Also, we can add a vibration model to notify users for different kind of triggers and events. We have a real-time circuit, clock circuit, and the processor that we are using is perfect for managing heavy digital signal processing workloads and performing neural networks. So it's a perfect processor for edge computing applications. So the first question when you are receiving, when you have that we have our own hardware, is why not using a market-ready device for these research activities? There are a lot of them outside. Yes, they are, but for example, the big players like Apple or Samsung or Huawei devices, it's not on their business model to support third-party integration. Their business model is focusing more on end users and commercial sales. So having communication with them to integrate their devices, their data to your solution, it's not an option. Other, let's say, smaller players like Garmin or WeThings, they support third-party applications, but they have specific demands on that. For example, for Garmin devices, you have to use your users to use their application, their mobile application, in order the wearable device to connect with this application and post data to Garmin's cloud infrastructure, which raises a lot of issues. For example, privacy, where this data will be stored, and especially in the healthcare domain, this is a big problem. Also, what about engagement? You are asking your users this besides your application, that is the main application that they have to use to support your use case, but they have also to install Garmin's application and configure the application as supposed to do. So a lot of issues raising there. For example, in the Garmin example, also they support an SDK integration. That means that gives you a specific piece of code of libraries to import to your mobile application and receive directly the devices from that. So this issue creating a lot of architecture problems. So our wearable devices having the capability, both capabilities of BLE and Wi-Fi, can simplify your architecture. You are able to select which kind of architecture layer you want to connect and receive your data. You want direct it to your gateway, your BLE gateway, or you want to post data directly to your cloud infrastructure to you, following your API guidelines. So this is a big advantage, especially for technical details, but can create and solve business issues afterwards. So avoiding using third-party application is a big benefit when you can get it. So, and also, of course, the biggest advantage is that you can test your MVP. You can test your use case with a decent hardware that can support your pilot flow, and being able to measure specific KPIs you want to measure and metrics for your pilot study before having the need to invest your own hardware. If this is the case, if your business case can support hardware development, of course you can continue using our custom wearables, but it's a great test bed to test before invest on your own hardware. So on the next slide, we can see in details our open source BLE interface that we used for the SAPES project. So having in mind that general knowledge of how Bluetooth Low Energy is working, we designed our services, our custom services and characteristic in order to make available the data we mentioned before to third-party applications. So this information is open source, is open to anyone that wants to test our custom wearables. So each service holds below a characteristic having specific permissions. You can read and you can write on these characteristics in order to receive or send information. And also you can notify, as BLE standard mentions, notifying is the difference between read and notify is that when you're reading a characteristic, you're reading once and you have to repeat the procedure again if you want new data, while when you are subscribing to a characteristic and you're notifying this characteristic means that you have a constant open channel between your software and Liberty device, in order when new data are created, you can receive it at once without being necessary to read again a characteristic. So under Vidavo service, we can see the Vidavo characteristic, where we have an example here is a specific. This characteristic offer a specific amount of bytes, as you can see here. We can measure the size of this byte array. So if a third-party solution, a third-party software, a third-party gateway read this characteristic, it will be able to, it will receive these bytes on this specific order. So on this specific characteristic, we're setting timestamp and PPG data. So timestamp is consisting of 1, 2, 3, 4 bytes that can be translated into day, hour, minute, and seconds when these data were created. And which are these data? So we're sending another 1, 2, 3, 5 bytes in order to let users know what is the current heart rate, blood oxygen saturation, respiration rate, and body temperature. As you can see, heart rate consists only for 1 byte, since it can be a value from 40 heart rate per second up to 118, which is the upper limit that our device is capable of measuring. But the same is on blood oxygen saturation. We can measure from 85 up to 100%. So we need just 1 byte to send this information. And respiration rate, we're able to measure from 5 to 35. So again, 1 byte is enough. But on body temperature is not enough, since body temperature is a float number. So we have 4 digits. And of course, we have the point. So as you can see here on the example, we are going to receive these 4 digits. These 4 digits is 2 bytes. And as you can see here, we are explaining on our open source integration protocol that the first byte is always the integer part, and the second byte is always the decimal one. So when you're receiving 24 3B hexadecimal bytes, you know that 24 is the integer part, it's 36. Of course, since it's a float number, you have to put the point afterwards, and then the second byte, you know, it's a decimal one, so it's 3B, it's 59. So from this byte array, these 2 bytes, 24 and 3B, you can understand that the body temperature on this given timestamp, it's 36.59 Celsius degrees. Also, another important characteristic that we have to mention on this workshop is the patient start service, which has the characteristic holding this information here. It's a characteristic that Liberty device stores data locally, and it's 24 hours updates, reset them. So again, we have a data rate of 3 and 4, 7 bytes that delivers the information related to heart rate average for the average of the day. Since you are reading on a specific time, the minimum, the maximum of heart rate, the steps, and the calories to this given time period. So again, you can understand that the steps and calories can be bigger numbers, so we need 2 bytes in order to represent them and send them to third-party solutions. Following the same logic, we can serve and receive other kind of data. So before closing this workshop, we thought that it will be important to give you an understanding that combining our raw data from the PPG sensor, the IMU sensors, the vibration model, and so on. Of course, combining with the BLE capabilities and the Wi-Fi capabilities, it's really easy. Having access on this raw data, you can create a lot of, and you can support a lot of use cases and a lot of research activities. So previous clients and Vidavo also, we used the same device, the exact same device as we used on the SAPES project. So the same hardware. We developed it once, and we are able to support at least these use cases you can see here. They have been supported the past 2 years. So with the same device, we can monitor athletes' rehabilitation in water. Also, we have been monitoring COVID-19 patients in clinics. Also, we are able to perform gesture recognition and find symptoms that may be related with allergic rhinitis symptoms or outbreak. We used the same sensors to perform again gesture recognition and correlate them with social isolation of the elderly, how their physical activity is, to monitor CVD patients at home and provide a triage and monitoring system for emergency departments. So all these use cases needed a hardware, of course. They needed data, real-time data for the users. So using the same device, third-party applications can use this data and support these use cases. And we'll mention one of them that proceeds with, which is the last use case example mentioned, that being able to perform this MVP and measure specific metrics on their use case, they're able to invest on their own hardware, as you can see here, but already tested their solution and already proved that their research activities have actual business value. So it wasn't mandatory to invest on hardware and in order to prove that their research activities have something to offer on the business framework. So they used our device, our custom wearables, in order to provide continuous monitoring on patients inside the emergency departments. And the concept is that using our devices, we're able to calculate heart rate, respiration rate, and blood oxygen saturation continuously, and send to ER doctors notifications where vitals, where the Liberty device was able to identify any health deterioration and let doctors know when a patient is deteriorating, what is the reason of the health deterioration, and also where this patient is located inside the emergency departments. Also, they used raw data from our wearable device in order to run neural networks that are able to predict if this patient will be hospitalized. Of course, they used other data like medical history, symptoms, and demographics of patients, but having a wearable device providing real-time data gives you a dynamic approach on your predictions. Dynamic, I mean that you have continuous predictions over patient's journey inside the emergency department. And as you can understand, this journey can last up to 8 hours. It's different to have a constant prediction while patients arrive in the emergency department and you have their medical history and symptoms and demographics. It is different to have continuous predictions. Each time custom wearables send a payload of data, a payload of vitals. So this was the main procedure, the main presentation. We present what we've done to Liberty project and how important it is to use custom wearables in different kind of use cases. So maybe we can have a 10 minutes break and return with your questions. Here is my email. Of course, you can ask anything you want after the workshop and of course after this break. So yeah, see you in